What up, everyone? Here we go again. Oh boy. So, we're kind of stuck right now. Yes, but I think that by the end of the stream we can figure out all the bugs that we have, that we created yesterday. And then we can actually look at a chunk. And that is kind of my goal for now. And then tonight we can do another stream where we will actually make some real progress. Because of course I'm not expecting, you know, that many viewers in the afternoon hours. So, would be a little bit, you know, unfortunate for people who regularly view the streams to just miss out like that. So here we go. We have our little voxel here in the middle, right? But the problem with that voxel is that it is basically 0, 0, 0. Right? If we force X, Y, and Z to not be 0 ever, then it just doesn't work. Look, just doesn't work. And now the problem, most likely, is the shaders. So let's actually go to the shaders. I believe I can open them in Visual Studio again. I don't know why they open in separate screens. I just wanna... Oh, you know what? I might as well open them in here, right? Geometry shader, like this, yeah. And vertex shader. Okay, so we have all of this, right? If we just force this, we just say float x equals 1.0, float y equals 1.0, and then float z equals 1.0. Will I be able to see something then? I will. Look at that. So then I will be able to see this voxel. So it is definitely the encoding and the decoding, because if I put 1, 1, and 1 in my vdata, then I cannot see it. Right? Even though in... Where is it? Render, World Manager. Let's just get rid of some of this stuff. Shader Manager, Render Manager. Yeah, it's in here. You can check this. Here we can see x equals 1, y equals 1, z equals 1, and then c equals 0. Here we don't do anything with the c, so then d should be... Where is d if we put it in hexadecimal mode? 0, 1, 0, 1, 0, 1, 0, 0. Right, so that is approximately what we are expecting. Okay. Big sip. Now, what we can do is maybe we can check this, right? Big versus little endian. Maybe that is the issue. So what we are saying now, so let's get paint in here, right? Like we always do. I always forget to set that up beforehand, but it's fine. It's fine. Okay, so now D, or our data, I call it D, just short for data, is going to be X, Y, Z, and then C, where C is color. So that will be given X equals 1, y equals 1, and z equals 1, and c equals 0. So that will be 1, 2, 3, 4, 5, 6, 7 zeros, and then a 1. And of course we just copy paste that 3 times, actually a 4th time. And then the last one here we turn into a 0. There we go. So that is what it will look like in binary, correct? Where this will be the X, this will be the Y, this will be the Z, and that will be the C. Okay. Now, if we want to read this out, we read this as an unsigned integer, right? And if we want to read this out, we can AND operator it with like 1, 1, 1, 1, 1, 1, 1, 1, and then the rest all zeros. And now what we will get from that is the 0, 0, 0, 0, 0, 0, 0, 1, and then 0, 0, 0, dot, 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 0, 0, 0. Okay, that is the integer that we will return from this. Now that is obviously wrong, because we don't want the integer like this. We also want to like move it back 24 the other way. Right, so we only have this left. I think that might actually be the issue. Why didn't I think of that? Hold up. I'm not shifting it back. Hold your horses. That... Okay, well, that's the issue, ain't it? So shift it back 24 times and then AND it with 255. Do that with this one as well. It's not a little and big endian one. This is 16, that is 8. All ending it with 255. That should just work. Oh. No, yeah, of course. No, still not, still not. So 0, 0, 0. Do you still work? That still works. 1, 1, 1. No, 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 okay. Doesn't work quite yet. So V shifting it out by 24. Ending it with 255. Shouldn't that be X? You can say something like, you know, the float Y equals 1, float Z equals 1. We are just checking X now. Doesn't seem to work. We can set X to 0 and then it should work, maybe. No, it doesn't. No, it doesn't. So the other data somehow conflicts here. Maybe it is a little and big endian thing then. So what if for X I do the 0 one? Right, and what if I then say I just let X actually range? Look at that. So we are actually increasing X here. Hold up. Still not quite correct though. Right? Still not quite correct because they're not touching each other. There's still space in between here for some reason. But it's almost as if this will actually give us the correct X. Will it though? Well, actually, so we do have these bits here. We don't want those, right? We only want these bits, so that is only 31. So we should end it with only 31U. And not with 255. Still doesn't make much of a difference. Now, if we need to flip the bits, right, I could do that. I could just say, well, let's do the not operator on all of this. Now we just flip all the bits. Doesn't work. Not operator doesn't work in here. Wait, that is the OR operator. What is the not operator again? Just like that. Okay, hold up. Binary and a not operator. Just want to flip all the bits. C++. That's easier to find usually. Why? Is there no not operator? Binary operators. Or bitwise operators, that's what I mean. XOR, left shift, right shift, not. Okay, that is the not. Okay, I forgot. So the not operator is this one. And I'm assuming that it's all the same, right? Yeah, then you don't see anything. And that is, of course, because... Oh, I know why. Right, because this will give us a new uint. So maybe we should not operator the vdata before we start. Then we should start shifting. Here, that does do something, but it's not quite what I want. So weird. What if I just do it like this, right? So vdata, shift that one 16. 31. This one 31. So if x equals shifting out 0, then y is shifting out 8. Z is 16. Right. Doesn't work. Oh, I am also declaring... Hello, Demir. I have to get rid of these. Yeah, we just... Okay, so that is... It does jump, right? And I guess it does do something. What if I go to render manager and I set this to J and this one to K? Hold up. hold up real quick. Okay. And on just X. Yeah, for some reason we are now... This is just the full cube, right? Y and Z are both 0 all the time. X is always 0, so I should now just have 1 point. Yeah. And if I say, well, I want more Y's, then it should go up. But it's making the entire square now. Which isn't quite what I want. And for Z, it should just go to the back. Interesting. Very, very interesting. Okay. Let's see, what if I make everything 0, but I actually shove the C in there? So now I do have a C. Still does that. It's so weird. Why does it do that now? If I do it like 24, 16, and then 8, as you would expect would happen. Here, that I'm getting random positions, basically. I'm just getting random positions. Why? 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 So how am I putting them in there? Right, we have X, Y, Z. So maybe we're reading it from back to front, right? So then 24 is C. 0 is X, this is 8, this is 16. Right, but that is what I had. So then in here 0, 8, 16. This should give me just one position then. But now it makes like this big box. (31U) is 11111, correct? Let's do binary to decimal, yeah. 11111. 31, yeah. So that is correct. Right. Let's go back here. Right. I don't get it. I don't get it. So we have X here. RGBA, yeah, we have X here. Yeah, we're just inputting X, Y, and Z. So that should be fine. If I would say something like, where do I put my colors? Here, right? So let's actually use the colors now. See if we can actually find color. Because I think finding color might be easier, right? Because we can visually see it. So in principle, the way that we have it now, this should be shoved out. I guess I can do it all at once here as well. Shoved out by 24. Right? And this, and this, and that, and that. Yeah. And I can say RGBA, yes. And then in the fragment shader, I can just actually write these. Doesn't work. Invalid operands flash in 20. Line 20. Oh, I need one more bracket here. Yeah, no, that makes sense. Still red. Why is it red? Wait, hold up. Why is it red? Huh? Out of all the colors, why is it red? So here, C should just be... what is red, right? If I do... I think it's C0, right? That is just... 1, 1, 0, 0, 0, 0, 0, 0. Which is red. But I don't want red. I want like blue, so I'll do it like this. Which is 3, 0, I believe. Very much still red. Okay, if I... Why is it red though? Frag color... This is that. So frag color is... geom color, RGBA, which is this. Then in the geometry shader, frag color is just normal color, yeah. So I don't know why it is red specifically. Shove it out 0. Now it's black. 8. It's also black. 16. It's red. 24. It's also red. Huh? So in here, right, if we just check this, D right now is just 48. Like D is 0, 0, 0, 0, 0, 0, 3, 0. So for some reason, it's finding 2 reds in here. How? Unsigned int, that should be correct. Data.length times 4. Yeah, because data is now unsigned ints. Yeah. Yeah, times 4. Yeah, data. Unsigned int. Size 1 per vertex, 0 stride, 0 offset. Yeah. Hold on. Okay. Continue. Let's say that we are only going to input C. Then we should get the same result, right? Yeah, then D has the same value. And our result is still red. Yes. What does red even mean? Yeah, so R is 1 for some reason and the rest is not. So what is in 192 actually? If we switch 192 is 1100 oh 0000. Now if we are truly reading backwards, then red should be on the other side. Right? So if we are truly reading backwards, then this should be 192, and this should be 3, this should be 12, and this one should be 48. Yeah, but now alpha is clearly not okay. You can kind of see through it, right? Make alpha 1, always. Oh, no, it's still the same thing, so it's not alpha. Yeah, now we're basically reading it backwards. We are doing this on 24, and saying N3, 12, 48, 192. But also C. Can make that C0. That is more red. 30 is less red. 0C is even less red, but it's still a little bit red. So it's almost like frag color. It's just red, but in different tints. Why? It is RGB, right? Factory R, G, and B, where R is 24 and 3, that is 24 and 12, 24 and 48. Yeah, so why does everything share the red color? Like G and B are just always 0, though. Yeah, I don't see a difference here. So what is... Maybe it is something with geom color. So in geometry here I have position and transformation. Yeah, and then I say frag color equals geom color 0. It's geom color 0, where frag color is vec 4 as well, and geom color is also a vec 4. And if I set in here, if I just set blue or green to 1, do I get a more greenish looking thing? I do. So it's actually not the issue here. No, let's only use green then. I can just put FF in here. And I don't see anything. Then I'm not even seeing anything. The hell? Oh, if I do 0, 0. I put FF in here. Don't see anything. Okay. Which means that we are probably not wanting to use 24. Maybe we do want 0. No. Oh, I'm reading it out here for the x coordinates. Let's remove x, y, and z for a second. Let's make everything 1. This black, okay. Okay, 8. Still black. 16. It's green. 24. It's black again. So it has to be 16, right? So the color is in the 16-bit range. So we are basically saying this here is the color. This is the color. How does that even work? Where are X, Y, and Z then? Wait, can I just find it? I can just say, okay, so C equals 16. Now let's go into Render Manager. Now I will make the Z coordinate green. Okay, so that is not where the Z coordinate is. Not at 16, maybe it's at 24. No. Maybe it's at 8. No. Maybe it's at 0. Also no. So I can't find Z in VData anywhere. Z just doesn't exist. So maybe I should just say that here. Like C equals 16. Z equals like this. It doesn't exist. Y equals. Let's find out where Y is. Oh wait, we are not putting Z in there. Hold up. Let's try that again. We're now trying 0. Okay, that doesn't work. Try 8. Doesn't work. You can try 16. 16 as well. So Z equals 16 as well, right? Of course it is. And 24 too for some reason. Maybe what we can do is we can just say, okay, only render the first one. So for size, just render 1, please. Excuse me. Excuse me. Okay, yeah, so just render 1, because maybe it's a problem of rendering everything on top of each other. Maybe that's what's causing issues. So 24 now doesn't work. 16 now doesn't work. 8 should work, but it doesn't. Then we have 0. Also doesn't work. So if we shove Z in by 8, we set that inside of our data, and so we just have, right, if we go here, we'll be able to find it. So if we go into our data, then the first index here should be 65280, which in hex is 0000FF00, which is exactly what we are expecting. Right, so why exactly, if we are just drawing the first one, can we not find any ones in there? Let's get rid of the AND operator. Okay, that is still nothing. We can... Wait, yeah, but this is just v data. Moved in by nothing. Meaning that this is just the raw v data. We are just dividing that by 3. So this should be like 65,000 divided by 3. This should be a very big number, and yet we see absolutely nothing on screen. So we are just not getting the data that we think that we are getting. Right, if I make the size bigger again, like what did this used to be like chunk size? Still nothing. Static copy. Can try static draw. Also no. Maybe we don't delete the buffer. No. Bind buffer is also not unbind our buffers. No. We are enabling index 1. Size 0. Unsigned int. False 0, 0. In short, unsigned int. Unsigned int 10 f11 f11 fref. I have no idea what that means. Unsigned short. Could try unsigned byte. Wouldn't make any sense, but you know. Unsigned int. VAO equals VAO. If we click on render, where is our render function? Render object. Okay, this all seems to be correct. Do we not maybe just GL draw like elements? And then points. Count, such as ro.size. Draw elements type. Unsigned int. And 0. What if we draw elements? That doesn't work. To read or write protected memory. Yeah, we don't have a single index buffer in there, right? You think it is draw arrays that is the issue? Let's not use the vertex array. Right, let's not have a vertex array here. But let's keep our vertex buffer enabled. So we are not getting rid of the buffer. So we do have the buffer here, the VBO. We don't delete it, we don't unbind it. But then we don't see anything. Right. What was the index of it? 1. So we can just go here and say something like just enable 1. Yeah, then we don't see anything. So that's probably worse, right? VAO. Okay. GL draw arrays. Let's look that up. Specify what kind of parameters to render, points, lines up, patches. Specifies a starting index in the enabled arrays. Specifies the number of indices to be rendered. Draw array specifies multiple geometric primitives with very few subroutine calls. Instead of calling GL procedure to pass each individual vertex, normal, texture coordinate, blah blah blah, you can specify separate arrays of vertices, normals and core and then use them to construct a sequence of primitives with a single call to GL draw arrays. When GL draw arrays is called, it uses count sequential elements from each enabled array to construct a sequence of geometric primitives, beginning with element first. Mode specifies what kind of primitives are constructed and how the array elements construct those primitives. Vertex attributes that are modified by GL draw arrays have an unspecified value after GL draw arrays returns. Okay. Let's say that I do want to just draw elements. And then what I want to do, I will just say my index array will just be a new uint array. Oh, just like 0. I will just draw 0. It's kind of working. Why? Even better, why? Byte vertex array. No, then we have size. We just want to draw 1, of course. But then it works. So maybe that's the issue, just to draw elements. I should be just draw elements, but without IBO. How do I do that? GL draw elements without IBO, without index buffer. Another option would be to have one single index buffer on the GPU that serves all the geometries that I need to render. That is still taking some memory on the GPU. That is an option I use for the common case of quads, but the separate triangles, GL draw arrays should be better. Okay, that is actually something that we could do, of course. So we will be drawing a whole bunch of these chunks, right? But all of these chunks will have the exact same index buffer. So I could just make one index buffer, just one IBO. That of size, right? Because that is relevant, that is why we didn't want an index buffer. So that will be 32 cubed. And then times 4. Yeah, because we just want an IBO that goes like 1, 2, 3, blah, blah, blah. Right? So we just have one index for every point. So 32 cubed. And times 4, because one index will be 4 bytes. Right? Well, actually, 32 cubed could fit in a short, couldn't it? That could most certainly fit inside of a short. So I could even use a short here, so times 2. So that will be approximately 64 kilobytes. To use that for everything, right, is not that much. So let's say we are rendering 25 x 25 x 25 of these chunks. What was that again? 25 cubed. 25 x 25 x 25 was 15,000. So approximately 16,000 of these. So dividing 64,000 by 16,000, so that would be approximately 4 bytes per chunk extra. If I would render that many chunks, then it is about 4 bytes per chunk extra, which is of course peanuts. Totally fine. 64 kilobytes we can spare. Okay. That is actually very smart. So I will go ahead and do that. That does mean that we need to just somewhere load in one index buffer. Right, so I guess, right? Private static no, not read only, so it should be an int. And this should be just index buffer, like chunk index buffer. I guess I can store it somewhere else, because of course for non-chunks, this doesn't really make any sense. I guess I'll do chunk index buffer equals 0. And then at some point, I'm going to have to initialize this. Right, and that won't be here. I guess I would need one public static void, and then init chunk index buffer. Right. Then what I can do is I can say, well, chunk index buffer equals gl.gen buffer. Then I can of course fill the buffer with data. So these two. Buffer the index buffer, and then I want to say this is of course element array buffer. This will be an element array buffer. Then the size will be chunk size. Yes. No, times size of a ushort. And then the data here will be another array that I will have to make. So a ushort array indices equals new ushort array of chunk size. Is there like a method to easily fill this up? Like array that will just fill everything with one value. Right, so not really. I'll just have to manually go over this. For int I equals 0, I smaller than indices.length plus plus. Oh, it's not a plus plus. Plus plus I. Indices I equals I. Convert that to a ushort. Okay. Then we can put the indices in here. Static copy. Right, that should work. Is not filled with 0. No, I don't want the indices to be filled with 0. I just want, you know, every single voxel to be drawn once. So I want to go over, I want to do 0 first, then 2, then 3, then 4, then 5, so on, right? This should work as long as I actually call it from CEngine. It's a little bit ugly like this. I don't actually like it too much in that regard. Render manager dot init chunk render buffer or chunk index buffer. Yes, maybe I should store it somewhere in chunk or something. I don't know. We'll keep it in here for now. And then what we can say is over here we can bind to VO, then we can bind buffer GL buffer targets. Wait, buffer target.elements array buffer chunk index buffer. Then we can unbind it over here, of course. There we go. This can just be 0. And this can be our actual count. Oh, and this should be unsigned shorts. There we go. And count, which will be chunk the chunk size. It's black again. Well, that's okay, because now we are saying that Z is shoved in by 8, and in our vertex shader we are not shoving it out by 8. Right, and then end to 55U, so I want to read the entire thing. Doesn't work, for whatever reason. Okay. Why? Size is chunk size times 4. Then data. Yeah, this should be times size of uints. Then data. Static. Copy, let's put all of that back. Type unsigned int. Let's check this out. So this is 1, yes, that is correct. Element array buffer, yeah. We want points. Count chunk size, that is, yeah. Unsigned short. 0, yeah, that should just be correct. Still 0 though. What if I just don't bind the element array buffer? Then I'm going to get an error. Yeah, then this crashes. That makes sense. I can put like the new uShort array here back and just say 0. Also draw one. Now it doesn't work again. So this used to work, but this was unsigned int. Maybe the unsigned short is just broken for some reason. No. In vertex. Let's get this. Oh, then it works. Then it works. So let's get short back. Unsigned short. uShort. And go. Still works. If I do 0 and then 1, and then I say, well, I have a count of 2. Does that still work? Does it scale? Yeah. Yeah. Now if I just bind the buffer, but I don't do anything with it, I just bind it. All that I do. Oh, now it's... I don't even know what happened. Oh, it doesn't like that. It doesn't like that. 0. Oh boy. It's the build for an hour. Yeah, no, that makes sense. Unable to copy. Why? Oh, hey, it works. Okay. So if I'm just drawing 2 or 1, it works. If I make the count bigger though, chunk size, then it doesn't work anymore. No, now it does work. It does work. Why did it not? What did I do different? I don't think I did anything different. I suppose. Okay. So now in vertex shader, so we can run it again. Then we will see just one green sad little voxel, right? Fine. What if I say, well, and 255U? Then it's black. I mean, that is very fair. Just shoved down by 0. Green should be shoved down by 8. isn't. Shifting down by 16 would still make sense. So it's just flipped around. Oh, yeah. By 24. Should be black again. And it's green again. Okay. Cool, anyway. So we'll go down by 16. It's at least green. So now if we go here, we're going to say, well, I want Y to be like that. Then it should be 8. Right? 16 still works though. 8 doesn't. Right. Of course. Naturally. Okay, so how does GLSL bit shift? Bit shifty. Bit shift in GLSL. Maybe there is something going on here. There is no shift operator for floating point data types. Yes, that makes sense. Floor that. Floor that. Do that. Yeah, okay. Yeah, that. Not really what I want. Bitwise operators in GLSL. This is in 2013. Yeah, supports all C's operators except address of, pointer dereference, and typecasts. The first programmable GPU had weak support for integer types in general, which was reflected in early versions of GLSL, which didn't support bitwise and or XOR, complement, and shifts, and modulo. Yeah, okay. I think the issue is this. The bitwise operator works on integer types only. For the OP, the solution you are hunting for is to make an integer texture. That's not what I'm looking for again. Bit ints into 4 8-bit ints GLSL. If it loads, ever. Oh. This is not anything with bit shifting. Everything here is in floods. What are they even talking about? Sure. Whatever. Whatever. Google, maybe Google knows. When was this? 2010. Oh, that's even longer ago. Holy crap. This was 6 years ago. Almost 7. Can you give the question more context? You can use 2 small tables of 60 entries to look up 4 bits at the same time. Yeah, so they're just using it like normal. As you would expect. But now I have to stay very normal index array, as I would always use these, you know. Indices.length plus I, xi equals I, gen buffer, same as what I do here, correct. Gen buffer, bind the Chunk size, size of view short, indices, static copy. Yeah. Could of course, just for now, something like this. And actually put it in here. Still black, of course. It might also be the 16 one. Then it is green. Is 24 still green? Yeah, that one as well. So it's still not in the way that I want it to work. Let's instead, right? Let's comment all of this out. Okay, let's comment all of this out. Then I'm just going to say data is just has one thing in it. Then I will say data 0 will equal 0. Then I will say data 0 and then plus equals and some color. Well, let's actually just make it equal to OXFF. Let's do that. And then the size is just 1 times uint. Just 1 data. Then this thing is just going to be 1. Indices.length, which is still 1, yeah. So that makes sense. Here the size of the array will be 1. Indices, static copy. Then down here, the size will be 1. Yeah, like this. Yeah, now I'm using 24. Maybe it's the whole float thing that's causing issues. Maybe I do something like uint g equals the data and 255u, right? And here I would say something like, okay, now I want to do float of g and then divide it by 255.0f. Still very much black. Could of course also in render manager make this FF. Everything is an F. Still not green. So you see, so I'm sending only ones there. Data 0 equals only all ones. There's something so wrong here and I just don't know what. Yeah. Indices 0 equals 0. Gen buffer. Byte buffer, chunk, index buffer. Yeah, maybe I just need to like unbind buffer and then unbind the elements. Array buffer. Something like that, maybe. Enable vertex attribute array 0, attribute pointer 0, size 1, unsigned int. Let's say I make this a float, right? Let's say I make this a float. Do I get anything there then? Yes. Make it an int. Then also no. Why does it work when I interpret the data as floats? In uint data. Okay, so vertex attributes, OpenGL. Maybe I can just look at this function. Maybe this already tells me. Index, size, type, normalized, stride, and pointer. Vertex attrib I pointer. Oh, do I need that? Do I need vertex attrib I pointer? Oh, is that just it? Specifies the data type of each component. The symbolic constants byte, unsigned byte, short, unsigned short, int, and unsigned bint are accepted by both. Additionally, half float, float, double, blah blah blah. Accepted by just a trip pointer. I'll try the attrib I pointer though. But unsigned int. In size, type, and just stride. Pointer. Int pointer, ref, int pointer. Int pointer.0. Why does this not work? Int vertex attributes integer type. Ah, okay. Integer type. Let's just see whatever happens now. It is green. I mean, this is indeed a void pointer. I don't know why this would be a void pointer. Oh, this is also a void pointer. Right, type, size, and index. Specify the location and data format of the array. Yeah. For type I pointer, only the integers. Integer types are accepted. Values are always left as integer values. Oh, if normalized set to GL true, it indicates that values stored in an integer format are to be mapped to the range -1 to 1 for signed values or 0 to 1 for unsigned values. Then they are accessed and converted to floating point. Otherwise, values will be converted to floats directly without normalization. Oh, I think that is it. I think that explains our weird behavior. So it has been just converting our uints to floats the whole time. Well, ain't that strange? Right, and then back to uints. Okay. So this may just work. Right. So now our data should just be 0, 0, or just FF. Which is just the color value. So now in here, yeah, N255U totally works. If I go out by 8 and then do N255U, then it doesn't work. Hopefully. Yes. Oh. Big. Okay, RGBA. Let's try this. So this should be 192, this should be 48, 12, and 3. Everything should be shoved back by 0. Divided by 3, yes. So maximum value can only be that. And then I can go back to R, G, and B. And then 1 for now. So this should give us a white. Whoa. That is red? Yes. That's green? Yes. This should be blue. Oh boy. Oh boy, I think we did it. This looks extremely promising. Yes, so this is correct. So data can now be uint of chunk size. Right, and let's actually put all of this in here. Okay, so now we have x equals I, y equals j, z equals k, and c equals a random color. Right, and we show everything 24, 16, 8, and 0, and then set that to D. Yes, and then in the vertex shader, so this would be 24, this would be 16, and this would be 8. We want the end 31, yes. Okay, let's just try, I mean. It's only going to draw the first one, actually, now that I think about it. Wait, because you're only uploading the first one. So we can say data.length. Yes, unsigned int. Yes. Indices, well, we already make the indices somewhere else, so that's fine. In here, I am still using the full size, yes. It should just be indices.length, actually. Static copy, and then when we are drawing in here, this should be chunk size, right? Unsigned short 0 points. Oh. Oh boy. That looks insane. That looks insane. I don't know why some have like double colors, so I guess I should move some things back a little bit. Okay, let's see. In world, I believe. Yeah, let's do an offset of this. Let's do an offset of -16 and -16 and -100. -100 is maybe a little much. -50. Okay, everything does look extremely weird because GL depth isn't enabled, I don't think. Depth test. So let's enable that. GL.enable cap. Enable cap depth test, please. Depth test is quite important. Yeah, look at that. Look at that. Look at that. Look at that. Oh snap. Oh snap. I think we done did it, boys. I think we done did it. Holy crap. Okay, now we can actually do some more interesting stuff where maybe we are not going to bind any index buffers. Then of course we are going to crash here, yeah, because we are using draw elements. What if I just draw buffers? Go. That just works. So I don't need the elements. Okay, so I will just remove all of that then. That's awesome. Right, so let's go in here. Let's get rid of this. It's ugly. This is ugly. That's all ugly. So it's great that we can actually get rid of that, because I really didn't like that piece of code. Okay, yeah, we're just stripping down all of our debug stuff now. Stripping away. Yeah, I suppose just encoding to a uint is fine here and then decoding later. It's fine. I don't want to go back to using the bytes like this. It's fine like this. Even if I were to get rid of the VAO, let's say I'm not doing the VAO, right. Oh, that does work, yeah. But then I will leave my VBO enabled. Does it just draw the VBO without needing a VAO? It doesn't. Yeah, I can try that again, of course. I can try it in here. I can say gl.bind buffer. Buffer target array buffer. Now 1, just to make sure. Yeah, no, that doesn't work. So we are then just going to use the VAOs. That's okay. That's okay. Apparently we need it. So then we'll just use it. Point vertex array 0. Switch these two around. Can even just delete this buffer probably. Yes. Okay. So that's awesome. Yeah, that's just awesome. Oh, snap. Snap, snap, snap. Also, if we reload, we get different colors, right? So now this one is like light blue. Yeah, now it's yellow. Yeah, so we do get different colors. I think it looks very neat. Also, how much time do we need to render one frame now? We're constantly creating and deleting so many objects. It's fine though. How much time are we using? So let's say we go into... Where's our render tick? Yeah. Can I just print my render time? Swap buffers is going to just take a while. Yeah, wait. So what I can do is I can disable vsync. Then I can just console.writeLine args.time. And this will be how many seconds of time elapsed. Okay, so I will just divide that by, or multiply that by 1000. That will be the number of milliseconds. So I can say something like this, right? This one, that one, that one. So elapsed time equals this milliseconds. Then when we create our window, you can say something like render frequency. We can set that to like 6000. You can try to see how close we can get. 16 milliseconds exactly. Okay, yeah, so vsync is definitely enabled. That vertical synchronization equals off. Right. Try that again. Yeah, so we are rendering in 2 milliseconds right now. The whole thing. And you can, of course, now say we are not going to render active worlds. So our baseline is 2 milliseconds, insane. Why? How? How? If I I don't do this, we are not getting all the object creations and removals, right? Yeah, look. So for some reason, this is just baseline. 2,00 milliseconds. Yes, if we do enable this, it is still to something milliseconds. So I guess that's like the minimum, 2 milliseconds, for whatever reason. What if I were to in world, right? Let's make like a second chunk. Chunk 2. Now I'll just do the exact same thing, but then like for chunk 2. Then in here, ID2. And then the Y offset, I'm just going to render it above it. So this one should be plus 16. Render object ID1. Just ID, yes. I also want to render ID2. Then delete 1 and then delete 2. So now we are rendering double the number of things. Still 2. Like, how fast is this? Okay, now I am seeing something like that, like 2.5 here and there. Did I see like a 3? I did see a 3 there. So from time to time, it is getting more time consuming. But, I mean, come on. We are rendering right now 64,000 voxels. Just damn. It's just all right there. 64,000 voxels. That ain't bad. Like with a geometry shader, I'm doing no occlusion culling now, by the way. I guess I do have depth test enabled, but I am drawing everything to the screen, and then OpenGL has to do the depth test after that to make sure that I only see the first pixels. That's insane. That's insane. It looks good as well. Like, to be fair, I think it looks nice. I think it looks nice. And everything that we had to do this whole time was to just say... where are we? Bucko. Vertex attribute pointer without the I here doesn't work with integer types. Oh... And now that I think about it, like, I vaguely remember myself running into the exact same issue, like some years ago. But, you know, you basically never have this issue until you have this issue. You know what I'm saying? It's really weird. But like 99% of the time, you don't have this. You just use floats, right? You don't need any weird integer type optimizations. You just use floats, and then you're happy. Everything works well, and you have no issues. But then one day comes, and you do need the performance. And then all of a sudden you realize, wait, maybe I can use integer types, and that will allow me to just shove random bits here and there, and then I can fit what's like 9 floats into 1 integer. You know, so divided by 9. That's quite a lot. That's nice. I'll do that. And then you run into this issue, and then you cry. Because it has genuinely taken me at least 2 hours to find the issue. Okay. Anyway. It feels worse, but I guess it isn't that bad if you look at it that way. Anyway, let's get the occlusion back. Let's see what our improvements can be. Right, so let's get all of these back in here. So then data has to be shoved here. And this has to be moved down as well, actually. Right, so these are all the occlusion bits. I'm going to put those in now. Works the same way. It is starting to take more and more effort. I don't know why adding the occlusion bits adds more effort. I guess that's just on the CPU side. Adds more effort. I guess that makes sense, right? On the CPU side, I have to do a little bit more work. I have to do all of these if statements. It's not pretty. It's not pretty. Maybe I can find like an optimization for that, but for now, that's okay though. You know what? I think that is actually the problem then, right? Or my limitation right now. I'm limited by my CPU speed and not my GPU speed. That's actually very interesting. That is why, if I didn't draw anything, it would still, you know, be 2 milliseconds. Because it was my CPU that was causing the issues. Not GPU. Okay. Now let's say I go into this geometry shader. Vertex shader first, actually. Get rid of these. Then I set the geometry occlusion back. So I have V position 0. Why? Why is this V position 0? Oh, that was V data. Okay, yeah, this can maybe more or less be like this. Ah, okay, wait, I see the issue. So I should have more like a uint x, uint y, uint z. I don't want to move this to floats yet. Right. Oh, you know what? No, that doesn't matter. Okay, wait. So I am going to have to move things out, maybe. So what I can do is I can say uint data x equals just this thing. It's just that. Because I don't want to bit shift more often than I have to. I can do the dy and the dz. They'll just be for data x, data y, data z. And then this is just dx. This is just data y. This is just data z. 16 and 8. And then of course I do already have to end 255 use these. Do I have to? I actually don't have to. I don't care if I have extra bits hanging at the end because I'm masking them anyway. Masking them out anyway. So it's okay. So in here I can use dx. Then end for you. That's not right. That's not right. Okay, so the occlusion for dx in the east direction, so the positive x. Let's go to the render code here. So here, this is the positive x one. E. Right, yeah. So this is east, this is the negative x, so this is west. This one is the positive y, so this is top. This one is bottom. This one is then north, and this one is south, right? Okay, so this one is it's a 1 moved in by 6. Right, so 1 moved in by 6. So that means I can now move it back out by 6, or I can just mask it, which is more likely what I'm going to do. Let's go back to my converter. Swap these. So in my binary one, north is the one at 6. So I have 1, 2, 3, 4, 5. I have 6, 7, and 8. Wait, no, this is index 0. That's 1, 2, 3, 4. This is 5. 1, 2, 3, 4, 5. Or this is 0. 1, 2, 3, 4, 5. And this one is 6. Okay, so that's 64. Right, so let's say I need to end it by 64. Right. It's east, now west is ending the same thing. One more, so that's 128, right? Yeah, that's 128. Okay. Now in here we have top and bottom, so let's replace these. This will be dy and dy. This will be top and bottom. This will be north, south. This will be z, and then north and south. So here we go. Now we have the occlusion. And we already output that, yeah. Okay, should give us the same result, yes. Same times as well, like around 4 milliseconds, which is still quite fast. 4.5. I guess it is adding up slowly but surely. Now in here, can of course do this. Right. So now I'm saying geometry occlusion. Geometry occlusion. Hold up. Oh, wait, I'm not moving these in. Right, okay, yeah. So how did I move these in? So this is 2U. 32U in here. This is in E. This is in north. This is in east. So north-south should be the next one. It's even 1. Right, hold up. Let's do this just over again, I guess. Because I'm too lazy to think. So let's move this one in by 1, right? Because this will either be 1 or 0. So we will move this in by 0, actually. The east. Move all of these in by some amount. So just move in by 1, 2, 3, 4, and 5. Right, it's fine. So, east is the very first bit in the geometry shader. So if we have east here, this is north, this is east. So now I have my east bit, which is and 1U. It's my east bit. If that is equal to 0, then there is no occlusion and I can just render it. Now for the west bit, that'd be the first, no, not the first, probably the second bit. So west, to south, this is west. This will be 2. Right? Then the next one, top. Next one is top. That will be 4. And this bottom, which will be 8. Then we have north, which will be 16. And then we have the last one, which is south. It will be 32. 32. Is that correct? I think so. Okay. Is this faster? It's not really any faster, is it? No, I think we are definitely CPU bound right now. But we can definitely, once we have a camera, we can fly in here and we can check it more rigorously. It's gonna of course just be A. There we go. 4 milliseconds isn't bad though. I mean, we have 60 milliseconds to work with, so we can make our program 4 times slower. Totally fine. Now we don't even have any major optimizations just yet. You know, like this just happens to be very slow. For whatever reason. Yeah, if I don't do that, and look at how much time I'm saving. So I'm thinking, right, if I just construct my array once, and then I just keep on rendering that same chunk until the chunk is changed, then I don't have to create this render object so often. And that will save so much time. That will save so much time. Just recreating this whole thing every single time. Also checking all of the neighbors. Takes a lot, takes a lot. What we can do, again, something that we discussed before, we can actually store our neighbors inside of each single voxel. So a voxel can have like data in there that says, okay, to the north there is another voxel, to the south there is another voxel, to the top, to the bottom, but to the east and the west there is no other voxel. So we are like in a wall or something. Right, in that case, you can say, well, you know, I guess we can just put that data that we then already have, we can just shove that into a XYZ. We don't have to do any if statements here, which is slow. We don't have to check anything like this, which is very slow. Right? We just shove these bits in just blindly because we trust that the bits are correct. And that will be it. That will be a lot faster. Also, we only have to change those bits whenever we change anything in the chunk, and not only that, we only have to change those bits for the voxels that are involved in the change in the chunk. So basically the voxel that is changed, and then the like 4 voxels directly around it, right? So it's only 5 voxels that you have to touch in total. And it might be faster. But then again, if you are changing a lot of voxels all at the same time, then that can add up very, very quickly. Right? Let's say that you... like in Roller Coaster Tycoon, right? Wait, maybe I can just show you. I have Roller Coaster Tycoon. Hold on. CT2. Do I just not have it somewhere? Open. Oh, it's OpenRCT. There we go. Here, y'all can see. So, right. For some reason, I'm zoomed in. Why am I zoomed in so much? I'm just gonna add the window itself. Hold up. Display, game capture, there we go. Add a game capture, and then we will just do... no, hello, we'll just do it. Here we go. There we go. It's loud. Christ. Why can I not like access? It's bad. It's really bad, guys. Okay, it's really bad. For some reason I cannot access the options up here. Like it's very much zoomed in on my screen as well. Like this is as far as my cursor can go. But let's just open up Force Frontiers, right? Frick, I can't do anything here as well. Let's try that again. Oh, why does everything have to go wrong today? What the hell is this? Open RCT2. Can I please? Oh, here are the options. Yes. I want to do window. Display resolution is just wrong. That is why. I guess I can do full screen. Pray that I don't crash. Don't hear anything anymore. So going to crash, aren't I? I'm just gonna crash the whole flippin' stream. Okay, let's go back in. For some reason, every time I go in here, I can't actually see the stream anymore. And also for some reason, the sound just quit. Oh, I can hear it again. If I now change the screen resolution to what it actually is, I believe it's this. If I then go to Windows, no, then it's still too big. Go back to full screen. Go one more down. Oh. This is a little bit awkward, not gonna lie. And then Windows. Yes, this works. Okay. Let me put it back. Voice. Max, listen. Spotify is still on as well. Okay. Let's go to Forest Frontiers, because this is what I wanted to show you. Right? We have gone all this way. Let's flip and do this. Let's say this is our world, right? Our Forest Frontiers. Oh, I'm pressing buttons. Now, if I just move one up, right? Just do... So this is one change in one voxel. So now the whole chunk has to update. Like the voxel that is here, the voxel that is there, the voxel that's there, the voxel... Oh, I guess if I add a voxel like this... Oh yeah, the old voxel doesn't change. Yeah, no, that's true. So the voxel that is here, 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 and here, the one that is below it and the one that is above it, now have to change. Right? They now have to, like, update. Okay, so that is 5 different updates. It's fine, it's fine, it's fine. But now what if I do this? Because certainly in our game we want a function like this. We don't want to be able to just change one voxel individually. We want to be able to do just like a mass thing, like bam. But now, okay, our game is probably not going to be smart enough to recognize, okay, so the only thing that I really do have to update is this outer edge. Right? Because we changed everything in here. Now, even if we are adding like a whole building, so let's say like we have this, right, in Roller Coaster Tycoon as well. We have some of these coasters that like have buildings with them. Can I find one of those? Yeah, here. It's a coaster with a building with them. So now, in these buildings, I also have to, like, change or check all the voxels around if I do that. Right? And these aren't all connected. So then I really do have to go through every single voxel and then check 5 around. And then for this one, check 5 around. For this one, check 5 around. This was a 10 by 10 area. So this will be 100 times 5, which is 500 different tricks. 500 different checks. Not even that bad. I mean, it's not even that bad. Right? But is it really that efficient? At that point, I'm thinking that that might actually be able to create a massive lag spike. Just blam, and then you have to do all those different checks. Especially if your building is just big. But... Oh yeah, and of course, especially if, you know, you are updating multiple chunks at the same time. Like a 30 by 30 area, which is still within one chunk, would be 900. Yeah, 900 different voxels, so 900 times 5, which is 4,500. 4,500 different checks. It's adding up. It's adding up, dude. So maybe that is not quite something that we want to do. Not all at like once in like one instant. Because that is a problem, right? If you need to do all of that in one frame, then you get lag spikes. And you don't want lag spikes. So let's turn on the music again. So maybe keeping this in here isn't such a bad idea, but we should definitely check. Because redrawing a chunk, you can queue that, and you can do that, you know, on like a separate thread. And it doesn't matter as much if you redraw your chunk the next frame. Like surely it will look maybe slightly laggy, but if you are running in 60 frames per second, then like updating your world and then seeing the change only in the next frame, you're probably fine. Like if you are going to wait 2 or 3 frames, well, okay, then you might start to notice, right? Okay. In any case, let's see. So in our world, in the render function now, we are creating and deleting every single time. So now what we could do is we could just temporarily do private bool initialized equals false, and then we can do something like private ID, ID0, and then private ID, ID1. Then we can do this, ID0 and ID1, and then we can say if, right? If not initialized, then do all of this. Set initialized to true. Otherwise, just render 0 and 1. There we go. Now, we used to be at like 4.5 milliseconds. Now we are at 2 milliseconds again. Like, all of that is just gone. Okay, sometimes 3 milliseconds. Okay, but yeah, we basically cut everything in half and we don't have this massive memory problem anymore. And we just have this beautiful little thing. We can, of course, also go into Render Manager. And in here, we can just say true or, and then here again, everywhere true or, so this will just always run. So I will now occlude everything. So that means that we should see nothing. Ah, that is not true. If you look at that. So this is always true, right? So I'm always going to say, what is the direction that is facing us? Z, right? So Z plus equals 1. Move around. Does this matter? Yeah, redundant. That's what I thought. I can shove it in 1, or I can shove it in 0. You can do it in 1, 2, 3, 4, 5, or 6, or 7. Okay, so this will now always run, so we should actually not see anything right now. So there is still something wrong here. As you can see here, the X is just this, right? And 64. I guess we should check north and south first. So DZ is that, but then by 8. We can do it and 64 and 128U. We can move it in by 5. 2 to the power 5 is 32. Right, that is 32. So then south, which is this one, should be 32, yeah. Still not drawing anything, or still drawing something. What is north? Oh, now it's not drawing it. See, now it's not drawing the front. We are seeing the sides right now, but we can see that all the sides are indeed drawing themselves. So for some reason this is not working. Geometry occlusion and then end 16. You can of course copy this. Then for like the first south, like these, I can disable these. And I can say something like, well, here I just want to shove in 1 by 0, 1 by 1. Right, so maybe it's a data transfer issue, maybe it's an in shader issue. So now I shouldn't see anything. Oh, doesn't work. Implicit cast, oh, of course. Keep on forgetting. There we go. Yeah, now I'm not seeing anything. Okay, so it is an issue with this. Right, it is an issue with this. So if I'm now saying, okay, north is this one, right? So if this one is 0, then I should see the north side of everything. Yes. And you could also see like the bottom side, for example. Yeah, we should look at that. It's quite pretty, actually. Okay. Okay, so that is not the problem then. The problem is this data here. So in here, am I sure that I am moving this data in? So I can say x plus equals and a 1 by 6. I guess I should try north, right? Oh, I can still see it. What if I look in here? If I look in here, what can I see? So I have my data here, right? Oh, and this is all... Oh, this is all 0. And yet I am seeing C0, C0, C0. And what is C0? That is just a 1. Correct? C0, C0, C0. C is just... Okay, let's check that out. I need to go back to like this website and then I need hex to binary. C0. Convert. Yes, 1 1 0 0 0 0 0 0. Yeah. That's what I want. So I guess that is correct. So in here, this is working. So C0 is being put in this data. Okay. So that's really just reading it out. Right, so and then I'm moving the data out. I know that this works. That is this, this, and this. Then for the north, we are saying and 64U. Yeah, that should be it, right? What if I do like and 32U? Still see it. Can do... Oh, 32 is what I meant. No. Can look at 16U. That's another bit. No, still not. I can look at 8U. No. Can look at 4U. Like, certainly DZ has something in it, right? What if I do like this manually in here? Then say and 64U. No, I can still see it. We know that this isn't the issue, so it's really just about reading it out. That's the problem. Okay. EXTYDZ. Feed data in here. Yeah. Okay, I'm back. So let's see here. Why doesn't that work? Because we just said we have OX C0 U. That should work. No, it doesn't. We do and Wait, OXC0U. Oh, of course. Wait, I see the issue here. Okay, so I shouldn't mask it because that doesn't work. So what I have to do is I have to first move the data out. Right, so in DX, I first would have to move it out by 6, right? And then I'd have to go for the 1U. Yes. So for the Z here, I'd have to say DZ. Move it out by 6. And say and 1U. Then move it back by 4. And then for the other one, it's DZ. Move it out by 7. And 1U. Move out by 4. So this should work. Yes, it appears so. Okay, now that makes sense. That makes sense. That is my bad. Move that out by 7. 1U. This is all 1U, of course. So I'll move it out by 6. Move this one 7. Yes, now we shouldn't be able to see anything. Yes. Now how fast is that actually? Just curious. 2 exactly. Okay, so rendering does add some time. And then in here we of course remove all of the truths. Remove these things. Now we only render what is necessary, which will give us like at most a 3 millisecond time. Yeah, so we can be 5 times as slow as this. Don't forget that we are drawing like everything. With that I mean I'm sending voxels to the GPU that I know don't have any visible faces. Right? So what I can do instead is in here I could make a list. Make this a list. Right? I can make this a list and then I can only add data to that list of voxels that are in some way visible. Right? Because now, right, what I have here is most of these voxels, all of these are true. All of these are true all the time. And so, you know, I'm just sending a bunch of voxels that have 6 occluded faces. And that doesn't make any sense, because I have to go through all the effort of checking it here. Then I actually have to like pack the data. Then I have to send it all to the graphics card. The graphics card has to unpack the data. In here, has to unpack the data. And it has to check the occlusion a second time. Twice, right? And then it has to check all the occlusion a third time. In here. And then it can decide, okay, maybe I'm not going to draw this. Quite a waste, quite a waste. But for now, you know what I'm thinking? I'm thinking that we did well. I'm actually going to make a screenshot of this. Maybe even I should go to, let's just see, right, in worlds. Let's just only draw the first one. And then I can make a nice screenshot here. Like this. That's, can I make it big? No, I can't yet. I haven't implemented. I haven't implemented that yet. Okay. Split screen. There we go. Wait, you guys can see anything for this entire time? Well, there we go. Oh, no one let me know. Oh, I'm such an idiot. Well, there you go. In any case, yeah, this last little bit of the stream was a little bit of a dud, wasn't it? Oh, no game footage to capture. I'm sorry. Yeah, well, sure. These afternoon streams, you know, not a huge success, perhaps. Well, I mean, I already said it, right? I just wanted to try to stream more. Just check how that went. Also just for myself, not just in channel views and that sort of terms, right? But I'm more talking about myself here, about, well, can I handle that much streaming? And then the answer is, yeah, I guess I can. So we did 2 hours now. I want to do 2 hours in the evening. I don't feel particularly tired or anything like that, so I think we can definitely make it. In the evening, I think I will try to make a camera class so we can move around a little bit. I think that would be nice. I think it would be very nice. Maybe some other optimizations. Maybe I can then just try to render more of these chunks. Make that maybe a little bit more robust. Yeah. No, I think that's a great idea. So, in the afternoon, or in the evening, we will have number 6, stream number 6, instead of 5.5, of course. And yeah, we'll do some camera stuff. I like cameras, and we can move around, and then we can see everything a lot better. That'll be quite neat. Okay. Well, hope to see you all then, for anyone who's still watching. And have a great rest of your afternoon. Okay. Bye-bye.